Hi and welcome back. And we are working on example number 2 on specific heat or specific heat capacity. And let us read the problem and see how can we apply the equation for specific heat to solve and determine the values that we're trying to determine. So at this point, when a 1,500 joules of energy is lost, okay, from a 0.12 kilogram object, so it means heat or this heat energy is being released, okay, so lost, so it's being released from the object. The temperature decreases from 45 degrees to 40 degrees, so there is a decrease of 5 degrees in terms of temperature. So we're actually reducing the internal energy by releasing heat. What is the specific heat of this object? So we're trying to figure out the specific heat. And at the same time, if we know the table, okay, if we know the value, we can go back to this table that we have right here. Once we solve for the specific heat, we can look for the number, and then if it matches with any of this number, then we can figure out what material are we looking for. Okay. So first step, as I always suggest, is to write down the equation that we're going to use, and which is Q MCP, specific heat, and multiplied by the change in temperature. Now we can further manipulate the equation by placing the final temperature minus the initial temperature. And we are solving for the specific heat, C sub P. So we want to figure out what is C sub P. Now, very simple, our mass in terms of kilograms. So 0.12 kilogram. As I always mention this in class, if we see kilogram, that is immediately your mass. Okay, so it says from 45 to 40 degrees. So it means you start from a high temperature to a lower temperature. So it means that from T sub I and then T sub F, T sub I is 45 degrees Celsius, and our final temperature is 40 degrees. And then the amount of heat, the amount of energy lost, which is our Q, is 1,500 joules. And in our case, since it's lost, that should be considered negative. So that's negative Q, negative 1,500 joules in terms of our Q, heat. Now, solution. Of course, first technique is to just write the equation. Q is MCP. Instead of using delta T, we know the different values, so let's use TF, which is the final temperature minus the initial temperature. And then next step is to plug in the values. We have Q, which is 1,500, but it's negative, so let's plug it in. 1,500 negative, equivalent to the mass of 0.12. And of course, we don't know our C sub P because it's something that we want to figure out. And then the difference in terms of its temperature, which is the initial temperature 45 and final temperature of 40 minus 45 degrees. So now we do have negative 1,500, which is equivalent to 0.12 multiplied by negative 5 degrees. By looking at this, we all know that negative and negative will cancel out. So C sub B is simply negative 1,500 negative 0.12 and 5, because I just have to divide both sides by the product of these two numbers that I multiplied as coefficient of Cp. So the value of Cp, or the specific heat of this substance, so why don't we just So negative and negative cancels out. So our value will be positive. So that's 1,500 divided by the product of 0.12 times 5. Don't forget the parentheses. So we're looking at a value of 2,500 joules per kilogram degrees Celsius. And if we go back to our table, if I will go back to my table, 2,500 joules per kilogram degree Celsius is basically wood. So I would say, therefore, the material is wood. So this is how simple the process is. By using the equation, we can determine, we can identify what material is this unknown material. Thank you, and see you again in the next example.